Oh. All right, everyone. Hello, hello, hello. I am so sorry I'm a bit late. I thought I'd get in a little bit earlier than this, but things have happened. So I'm just sharing this on Instagram for those wondering what I'm up to. So let me just share this. So let's do some learning. For the next. Okay, let's go. Right, so we are again talking all about we are going to talk all about the Kubernetes exam. Okay, so I'm a little dazed right now because there's so many things that have happened. Oh, also, I learned if you're watching this now and you tuned in yesterday, you might be like, oh, the thing has changed, the quality, and that's because I changed it yesterday and I managed to learn and understand how it all sort of works. Oh, my headphones aren't working, that's why I was very confused. Hold on, let me just make sure. Oh, okay, that's all good and working. Okay, I am sort of all over the place because I've had a busy morning. But I really wanted to spend some time in focus mode, just going through the Kubernetes and Cloud Native Associate exam again, and just going through some of my learnings. The reason this stream is a little delayed compared to when I said I'd be live, it's because I'm adjusting this live as well. It's because I was trying to get my iPad to work because I wanted to try and get the iPad to work so I could start showing stuff off, like do some drawings or something. That's what I was hoping for anyway. So yeah, so sorry about being a little late. Just trying to share my screen. I'm doing this all live. You can see me playing around with OBS right now, like struggling. Oh, this is genuinely the most, at least you can all see how I struggle in the back. I don't know how creators, I'm sure you get into the mood, into the groove of how these things work, but as you can see, I am faffing around with my settings. I still haven't got a really good setup that I really love, but I think this might be, what is this? Oh, yes, I remember now. Okay, cool. Oh, it's a quick hello from William. Thank you. Thanks for saying hi. Sorry about that. Okay, so let's keep on going. Let's keep going. Okay, let's start. Right, I've got a glass of milk. I'm all white today. I've got my glass of milk. I've got my headphones. I've got some water. I've got my iPad. I've got my pencil, and let's just go through this. So yeah, again, we're going through the Kubernetes and Cloud Associate exam, and it is the sort of foundational level exam to help people get into the Kubernetes and the wider cloud native ecosystem. Bit of background, if you haven't tuned in before, I started studying for the CICD, the Certified Kubernetes forgot the name already. Certified Kubernetes Application Developer exam earlier this year. Didn't continue with that because I changed jobs, so I didn't go through with that. But I would like to continue and learn more throughout the next few months, just because I feel like I haven't been able to get into the zone in terms of like what's new in tech. Like I've played around with Kubernetes before in my old job, but I feel like I never really did a deep dive. And this revision has sort of forced me to remember the things that I learned before and sort of highlight what I didn't know. So that's why I'm going through this now. But yeah, so yesterday I went through, as I said, I had the Linux Foundation had a essentials course that I went through. So I went through most of my notes here. And last night I also went through working with Kubernetes section, the working with Kubernetes section, which is more of a deep dive on like pods, different Kubernetes objects, and how to schedule pods with different workloads and stuff. So yeah, I'm really excited for this one. Looking forward to seeing how we get on. Okay, cool. I'm just checking that everything is running okay. And yes, okay, cool. So I wanted to do some drawing today, actually. There's different things I want to touch on. I think I might continue just going through my notes. So chapter 5, which is around the cloud native application delivery, and then observability. So maybe we can go through that first. And then I wanted to draw out the Kubernetes architecture a little bit. Not from memory, but just to maybe explain all the different components. So yeah, let's just go from chapter 5, Cloud Native Application Delivery. And like I said, this was part of the Cloud Native Essentials course that was part of this bundle that I bought. So this part should touch on, I would say, all of these sections here. So when you weigh them all up together, that it is a very important section. So it's important that we go through it. So yeah, like there's different objectives as part of this chapter. First one is discuss the importance of automation in integration and delivery of applications, understand the need for Git and version control systems, explain what a CICD pipeline is, describe the different steps, describe the ideas of infrastructure as code, describe the principles of Gitops and how it integrates with Kubernetes. And yeah, that's this section. So yeah, let's go through all of that then. So in terms of describing the importance of automations in integration and delivery of applications and the need for Git and version control systems. So all of this stuff, I actually am not going to go into much detail because I feel like I'm quite comfortable with my understanding of that. So I'm not going to read it out loud really. But the CICD pipeline, I think, still need some clarification, I guess, on that. So I'll just talk through that. So in this case, what CICD pipeline is, it describes the different steps in deploying an application, configuring, or even infrastructure. So the continuous integration part specifically is the first part of the process and describes the permanent building and testing of the written code. It's highly automated and uses version control, which allows multiple developers and teams to work on the same code base. So let's just make that bold. So that's the first part of the whole CI/CD process, the part of the pipeline. And yeah, as it says here, it is the permanent building and testing of the written code. So you write some code either in GitHub or other Git repos, and then continuous integration is the next part after you build after you write the code and you want to build your code and then test that code. So that is that first part. And then I might actually have that written down. So this is the first part of the process. So you have your source code. You have your source code. Then you have your, then you start building that source code. Then you have testing that source code. And this bit here is all, this bit here is all CI. Okay, that looks like it's it's very much like, oh, this is what that means. Like, I'm just changing this live again because it's bothering me that it doesn't go to each corner. I think it's because I've not got the resolution correct. So let's just, yeah, let's do that. That looks okay. Okay, cool. So build your source code and then you test it, that's CI. And then continuous delivery. The second part of the process. Oh God, I don't want that. We want to do the second part of the process and automates the deployment of the pre-built software. In cloud environments, you will often see that software is deployed to development or staging environments before it gets released and delivered to a production system. So let's like break that down then. So that means, this is you know what, we should actually, actually, let's break it down first. Okay, so in cloud environments, you will often see the software is deployed to development or staging. So right now, so at this stage, we've done the CI part as above, and now it's the CD part, which includes deploying your source code or app. At this point, it's not really source code. It's sort of like, it's your application or whatever you're building at that point, isn't it? And this is CD. And sometimes this part is actually in dev and staging. I know I worked in my first tech job. We had several different like staging environments to test things before it went live into production. So you sort of deploy it into dev, into staging, into more staging, or straight into prod. But usually there's a few tests, and each environment is they try to be as similar as they can as prod, so you're able to just go through that and see how likely it will act in the real world, essentially. Awesome. Before it gets released and delivered to the prod. Yep. So we got that. And then to automate that whole workflow, you can use a pipeline. So other pipelines that you can build is like Jenkins, for example, scripts. So you can actually add all your scripts. You create scripts, add into Jenkins, for example. I think, are the cool kids using GitHub Actions these days? I guess so. GitHub Actions is one. And it scripts all the steps involved in the CI and the CD part of the thing, involved running on a server or even a container. Pipeline starts. So yeah, essentially, you create the scripts and the steps to deploying your application into prod. So that and this also includes running. This also includes I think what am I trying to say? I'm so out of it today. My brain is so like fried. Let me just remove that. You can all watch me have my milk. Scripts to deploying your application into prod, and it also includes, and yeah, so what I was trying to say, and once this is built, it should be automatic so that next time you change your source code, the pipeline just runs. And so, yeah, CICD are push-based. That's essentially what I've said here. So if you make a PR or you commit, the pipeline starts. And that just helps. That automation is really, really good so that when it comes to new commits or creating new PRs, there's an environment there ready in dev or in staging, so you can just get started, really. And see what it looks like in staging, see what it looks like in dev, and then eventually that will give you clues to what it will look like in production. So yeah, and I didn't fill this part in, discuss the idea of infrastructure as code, but we can complete that together right now. But essentially it just means what it says on the tin, writing code that will create / provision infrastructure. For instance, using HashiCorp's Terraform. So the point of this is you have a repeatable infra that can be destroyed, and then yeah, so you have a repeatable infrastructure that can be destroyed, and then that can be destroyed and then instantly recreated by just using the same code. Yeah, so that's essentially what that part is. And I'm quite familiar with infrastructure as code because in my old job, that's all I sort of did. And that was really cool. And it's like that saying, don't treat your infra as pets, but cattle. Awesome. Discuss the principles of Gitops and how it integrates with Kubernetes. Gitops is a very new thing for me. I'm still trying to learn about it and understand what is going on and how it sort of works. So I'm still sort of learning that. And yeah, so let's go through this together. Gitops takes the idea of Git as the single source of truth a step further. Okay, so we know that Git is used as a single source of truth. Integrates the provisioning and change process of infrastructure with version control operations. So PR raising is best practice. Git pods. I always think of Git pod. Git Ops. The PRs are used to manage infrastructure changes. It is pull-based, i.e. an agent watches the Git repo for changes. Let's break this down. So we've got an agent watches the Git repo for changes and compares the definition in the repo with the actual running state. If there is a change, the agent applies the change to the infrastructure. See, that sort of makes sense to me, but it still doesn't really. I don't really understand. Is there a picture? So dev creates a pull request with some changes on the source code, and then creates a pull request that gets approved and merged. And then the CI part compares the two differences and then I guess applies it. I don't really understand this diagram. Is there a better one? Okay, no, something that's just Gitops. Oh, here you go, Gitops in a nutshell. Let's have a look at this. Infrastructure as code, config management, and application code. Yep, that's the source of truth. You update your Git. You have your CICD pipeline, runs a series of tasks resulting in the updates of the runtime environments to match the source. I don't really... So I guess Git will be like, oh yeah, there's definitely been a change to my config or my source code. So then CI/CD will just automatically create it and automatically, is that what it's like? Still learning. Is it more than just a buzzword though? Is it though? Because it sounds like a buzzword to me. I still don't get it. I don't get it. Git Ops takes this a step further, adding additional automation via infrastructure delivery pipelines, resulting in more robust, streamlined processes. I don't get it. Many modern IT organizations already support their... Like, give me an example. Who does this? I just need to understand. Additionally, okay. Resource provisioning. So if something changes with the configurations, traditional operations would have to manually implement at an OS or system level. Whereas with GitOps, it's automated via the configuration management system. I don't get it. I guess essentially it's creating GitOps is just automating infrastructure changes. Okay, so if we apply this to Terraform, for instance, say, is it sort of like how, you change your Terraform code and then you need to do a Terraform apply, but normally you have to do a Terraform apply manually yourself, whereas GitOps does a similar thing where there's some sort of agent or something that watches the repo for some changes, and then if there is a change, it will then say, hey, let's do an apply to update that. So it's all sort of automated, so you don't even have to think about, when you'd sometimes get tickets as a DevOps engineer or an operations person, we need to update all of our Ubuntu instances to the next version. So instead of that, there's all of your configuration is stored in Git, and then since it's all stored in Git, it will then be put into so since it's all stored in Git, it will then be put into it will then compare the two instances, the two versions, and then be like, hey, it's been updated, so it just automatically does it itself. So we change there's a configuration file that we change from one version to another, and then it will then pick that up, apply the same rules as CI/CD, and automatically change it. Okay, that's pretty cool. It'd be cool to see like an example, like of an organization that has done that. But it seems like a cool principle, I think, if I understood it correctly. It'd be cool to see like an example of like a Gitops file or something. Oh, keep typing in Gitpod. I meant Gitops. Oh, I can always trust GitLab for some information. How do teams put Gitops into practice? It's not a single product, plugin, or platform. Gitops workflows help teams manage IT infrastructure through the process they already use in application development. So infrastructure as code, one source of truth. Okay. MRs, who uses MRs as a change mechanism. Okay, so say we changed the configuration file that specifies like an infrastructure, then we change that, we create a pull request or a merge request in the case of GitLab, and then the MR will then be reviewed. And then once it's been approved, CI/CD will kick in. And then that CI/CD, once the new code is merged, the CI/CD change the environment. Oh yeah, it's exactly what I sort of said earlier. Okay, right, okay, that sort of makes sense. That's really cool. Okay. Yeah, I can imagine this being like DevOps, for instance, like DevOps practices being quite a like a practice that would take quite a few organizations to make happen. Like, I just think of my first tech job, because I always refer back to that job because I was like, I did so much like different engineering in that role, and the infrastructure team there, I can imagine them implement something like this, but it would take quite a bit of like a mindset shift for them to think it through, to get it through the door. But I can see it being very helpful, actually. Yeah. Cool. Thank you, GitLab, for a very clear equation. This is sort of what I wanted. This equation is what Gitops is. Let's just remove that because that doesn't make any sense. And then let's just put this here, because that, in my head, makes sense. So thank you, GitLab, for that. That's exactly what that's it in a nutshell. Amazing. Thank you for letting me go down that deep rabbit hole to try and understand what that means. Okay, so we're actually now in the final chapter, chapter 6, Cloud Native Observability. Fun fact, it took me ages to say observability, like the word observability. Oh, I'm jinxing myself. And it was really tough for me to try and say the first few times when I first like heard it, but getting there. Cool. Right, so let's go. Let's get back into it. Cloud Native Observability. So this section looks at how can we track all the microservices that we talked about yesterday? How can we analyze all the data that is collected? Observability. I meant observability. Observability equals monitoring. So that's essentially what it is. So in order for you to understand your applications and all your different services, how are you going to make sure that you're aware of how it's all set up? How do you make sure that you're aware, you understand the health of it and how it's doing, instead of just being, alerted by a user who says, hey, this isn't working. It's not working for me. You never want to be in that position. You always want to be a step ahead, that you have the correct monitoring systems, the correct alerting systems for you to really understand before it reaches your user. That is the end goal. So telemetry is a way of measuring and collecting data points, then transferring it into another system, which is, let's just remove this, into a centralized system. Let me just triple check, because I feel like telemetry is metry. I thought it was a tool. Open telemetry. Okay, cool. So open telemetry is like a tool that will help with all of this data collection and monitoring and observability. So let me just put this all here. Example tooling. So data can be divided into 3 categories. So this is referring to the data, the logs collected from your observability and monitoring tools. So let's just. Oh, I got worried then. I thought I went off live. I am still on, aren't I? Yes. It's so stressful, like monitoring everything. Like, monitoring everything. It makes sense. Cool. I'm glad it's still working. Okay, just triple checking. Yes, it does. Awesome. Okay. So, let me just move this. Sorry, I just need a bit more light, I think. Yeah, no, that'll do. That'll do. So data can be divided into 3 categories. You've got logs, metrics, and traces. So what logs talks about is logs are the messages that are emitted from the application when errors, warnings, debug information should be presented. Unix and Linux programs provide 3 I/O streams from which 2 can be used to output logs from a container. Yeah, you've got this standard input to a program, standard output, and standard error. Errors that a program writes on the screen. You have different types of logs. You've got node level logging, which is the most efficient way to collect logs. You've got logging via sidecar container, and we talked about a sidecar container yesterday, I think. And what it refers to is having another container that is like a sidecar, where it sort of supports the main container. So logging via sidecar container, it collects the logs and ships them to a central store. I think, does that refer to ships them to a central store? Does that mean the sidecar collects the logs and then ships them? Or does that mean the application gets the logs and then ships them to the sidecar container? That's a very good question. So let's just triple check that. Yeah, these images are so helpful. This is exactly what I need to add to my notes. Does that add? Ah, yes, nice. Okay. And then we have okay. Feel like logging via sidecar. Okay, so you've got your first pod. You've got okay, so you've got your app container, you've got a streaming container, takes all the logs into the streaming container, and then the container puts it to a central place. It creates a log file .log. Okay, cool. Using the standard output. And then logging agents pod, I guess, takes that log. And then there's a central logging backend. Ah, cool. Okay, cool. Yeah, that makes sense. Let me just do copy image. Amazing. Application logging pushes the logs directly to a central source. So that's just more of a direct thing. So that's still sidecar. Is there not another one? Yeah, directly. Here you go. I wish this was, I know this is cheating, but like, I wish this was available in the KCNA exam. Like, obviously it won't be. That makes no sense to have it there. But like, having the docs available, that would be super cool. But yeah, okay. So this cluster logging that exposes or pushes logs directly. Yep, so you've got your application container, then you've got your backend. And there's sidecar container with a logging agent. So instead of having oh, okay, so you have a sidecar container with a separate logging agent that you have configured specifically to run your application. Yeah, that makes sense. Shipping and storing logs can be done by tools like FluentD. Now I need to Google what that is. Open source data collector for unified logging layer. Oh, cool. Oh, shit. Sorry. Oh, I wish, can it not? Logseek, what is going on? FluentD or FileBeat. What is FileBeat? Oh, it's part of Elastic. That's cool. Oh yes, I remember using something similar. Oh, someone's in my comments. Hello, I'm a complete noob. How can I get started with cloud native? I'm pretty much a noob as well. And, I would say like actually try and do this Kubernetes and cloud native associate exam maybe as well. That's probably a best place to start. I think that was the whole point of this certification, to try and get more people into the cloud native ecosystem. Yeah, I think it would be super cool. Like, just if like, I know personally I learn the best when I have structured learning, and that's sort of why I started doing this course, because it gave me a bit of a understanding of what to expect and what I should be learning and what I should know from like end to end. And so, yeah, I think that is probably the best place to start. And yeah, I think that's probably the best place to start. And maybe get involved with the CNCF wider community. Like if you go on Twitter, type in CNCF on the search, you can find so many cool people who are CNCF ambassadors or CNCF, like just community members. There's so many communities that you can be a part of. Just drop in and say hi. I think they have a Slack channel actually for their community. Might be worth a look. I think that's probably the best place to start. But yeah, thanks for tuning in. So yeah, FileBeat is an Elastic product that essentially does the same thing. Lightweight shipper for logs. Also open source Grafana and Loki. And it stores all the logs as JSON. Metrics, quantitative metric measurements taken over time. This could be the number of requests or error rates. Yeah, so this is another data type. So let's just go back here. So number 1 is logs. Number 2 is metrics. And number 3 is traces. So metrics is the quantitative measurements taken over time. I think that's what we need to stress here. No problem. Thank you for tuning in. Hey, Tom. Nice to see you here again. Thanks for dropping by. I'm here again, just talking. After my live stream yesterday, I had a bit of a sore throat, and I sort of still do. But then I was like, whoa, I learned so much today, so I really want to continue. This could be the number of requests or error rates. So yeah, that's the measurements. Whereas traces track the progression of a request. So yeah, that makes sense. It's like a tracing from one point to the other and how we got there. Traces are used in distributed systems that can provide information. That, again, makes more sense because you've got all the different microservices in the cloud native ecosystem. And so you need to have like something like traces in this case, to like put it all together so you understand how something happened from one point to another. So that makes sense. What's the app you're using on the left? Oh, yes. So this app is called Logseek. I actually have a blog post coming up next week on Wednesday. I'm shipping it. I schedule all my blog posts, but next Wednesday I have a blog post where I talk about how I write notes, and I'll give you a sneak peek. I write notes in 3 different ways. I use Logseek, which is what I'm using now. It's like Obsidian, but it's more, I like it better just because it uses bullet points, and that's how my brain works, in bullet points. So I write most of my like day-to-day work notes on here. And then I also use Bear, which is more of the, whenever I want to write a blog post or something in a longer form, I use the Bear app. And then on the third thing I use is just Apple Notes, which is just a dump of stuff, like a dump of information that is just like smaller notes. But yeah, this is my favorite for note taking. It's really cool. It's really great. Cool, and we're reaching the end now. So as part of this chapter on cloud native observability, whenever we talk about observability, we have to include Prometheus. So Prometheus is a monitoring solution that is a standard tool that integrates, spelled that completely wrong, integrates well in Kubernetes and the container ecosystem. Whoa, losing my voice already. So, like we said, metrics is a quantitative measurement taken over time, and that's what Prometheus does. It collects metrics that were emitted by apps and servers as time series data. So these are simple sets of data that include timestamps, labels, the measurement itself, and Prometheus data model provides 4 core metrics: counter, gauge. So counter is a value that increases, gauge is the value that increase and decrease like memory size. Histogram is simple observations like request duration or response size. Summary, similar to histogram, but also provides the total count of observations. Okay, cool, yeah. And then a Grafana dashboard helps you see all the Prometheus data points. And oh yes, it is very dope. I hope you mean like the note taking. Do you mean Prometheus is dope? It is dope, is it? It is very good. And Grafana dashboard, yeah, helps you see all the Prometheus data points. And again, alert manager. So you have 3 tools here. You've got Prometheus plus Grafana plus Alert Manager. Alert Manager does what it says on the tin, configures alerts when certain metrics reach or pass a certain threshold. When a alert is firing, Alert Manager can send a notification to your favorite persistent chat tool like Slack, email, or whatever you use. And then let's just head over to tracing. So tracing describes tracking of a request while it passes through services. So I guess that's a bit different. No, that is the same. I was going to say it's different to traces, but no. Okay. So similar to what we talked about earlier with the different microservices and how it all lines up, same sort of thing. So it describes tracking a request as it passes through services. And Jagger, how do you say this word? Jagger. I've seen the tool before. And it essentially consists of multiple units of work, which represents the different events that occur while the request is passing through the system. Amazing. And then the last part of this, I actually whizzed through this section when I was going through the Foundation Essentials course, and it was around cost management. And that was because I did a lot of cost management related things in my AWS Solutions Architects Associate exam. And also, I was part of an SRE team that looked straight at cost management in the cloud. So I feel like I'm quite well versed there. But essentially, these are the 4 things you can do to reduce your costs in the cloud, because in the cloud native ecosystem, it often feels like you can spin up so many cool things, because it's like, you don't see a physical thing like when you set up a server yourself, like a physical server. So when you start opening instances in the cloud, you're sort of like, oh, it doesn't really exist. It's just there. It's free. But then you get the bill at the end of the day by AWS and you're like, dang it. What is this 1 pence? What is this? You know? So yeah, that's why it's important to manage your costs in the cloud. And you can do this by identifying wasted and unused resources, by sizing your instances and your resources to the correct size. So don't use more than you can't, you don't need. So make sure that if you're only hosting a small blog or something in the cloud, you don't need like a full-fledged Kubernetes setup for that, or managed Kubernetes setup for that. You can just put it in a server. I mean, yeah. Or if you do want to do it in Kubernetes, make sure you have all the different resources in a, you've really optimized that instance. You've really optimized your setup, because otherwise you're just wasting money. Reserved instances. So this means you actually reserve specific instances rather than just having instances on the fly that you just create. And then you've also got spot instances, which are more instances that you create on the fly, but you only get charged, I think, per hour or something like that. I just want to verify that, because otherwise I've got that completely wrong. Spot instances. Oh yeah, that's the one. Sorry. Yes. Spot instances uses spare capacity. I'm just going to put uses spare capacity. Amazing. And we've reached the end there of the whole thing. I did it in yesterday's session. I did it today in today's session. And yeah, just very excited to continue learning. I think now, just to go through it again, let's go through it again from the top. Well, we're not going to go from the top, but what we are going to do is I actually want to review Kubernetes a bit more, because as I said yesterday, Kubernetes weighs 46% as part of this exam. So maybe let's look into that and focus our energies there. So let me just, what I'm going to try, this is an attempt. What I'm trying to do is I'm trying to connect my iPad to OBS, and let's see if this works. I've accidentally made it black and I didn't mean to. Oh, you can't even see that yet. No. So let's just go NDI, start broadcast. Okay, and then we go onto OBS. Let's just remove these. Oh, not me. Remove the windows. And then, can you see that? Oh, you can. Oh gosh, cool. Oh, cool. Okay. Can you see this? Let's see. Can you see that? You can. It works. Amazing. Okay, cool. So let's, oh my gosh, why is it, I didn't mean to do that. Why is it, wait, is that pink? That shouldn't be pink. Why is the background pink? That's not good. I don't want it to be pink. I would be a terrible teacher right now. Like, I'd be a terrible tutor, because I'd just be like focused on how the canvas looks before I can actually get into it. I just realized as I'm looking down, you can only see the top of my head. So I'll try and stay up, and I'll try and go from here. Okay. So in this case then, let's talk about Kubernetes. Let me just open up my notes and the things that we talked about yesterday. So let's just focus on Kubernetes. Let's see what, yeah, let's focus on it. Let's just talk about it. It's 46% of the exam. So as we said, Kubernetes is a container platform. How? I'm in a meeting, but this caught my eye. Yeah. Oh, thank you so much for chilling out and listening in. I hope you don't accidentally put your volume up and then it just like blasts out. That's embarrassing. That's happened to me before. Okay, so we'll just talk about the architecture of Kubernetes and what to expect. So yesterday we talked about how Kubernetes is a container orchestration tool. So we've got our different containers. Here they are, containers. And oh, cool, it really does work. So we've got our containers here floating about. I'm getting suddenly very self-conscious because I'm actually not very good at drawing. So we've got our containers here. And what Kubernetes does is it gets these containers and puts them in a Kubernetes cluster. And this way, when you put it, I'm too much of a perfectionist to be doing this. Let me just start again. Let me just put this here. Okay, so these go into a Kubernetes cluster. And then we've got our Kubernetes cluster here. And the reason it puts the containers in the Kubernetes cluster is that's the best way to manage them and orchestrate them. So instead of just running a Docker, several different Docker commands to have to spin up several different containers, you can use Kubernetes to manage all of that yourself. So this is the cluster. And as part of the Kubernetes cluster, you have different parts of it that create that basically make up what Kubernetes is. And so in this case, we've got a control plane, which is like the brain. So we'll just call this control plane. Oh, yeah, okay. And then you know what? Let's make this bigger because it's not having it, is it? It's not good. Oh my gosh, this is terrible. I had this whole dream where I was like, oh, I'm going to be so good at drawing this out. Okay. So we've got a control plane that makes up what Kubernetes is made up of. That's our control plane. And another part of Kubernetes is this, which is the worker nodes. Okay. So this is what our Kubernetes cluster are like. We've got containers 1 and 2. And these containers get scheduled, gets managed by Kubernetes, and they live inside a worker node. So I've put worker node, but you can have different worker nodes. I'm just going to separate. This is really bad. Okay, so we've got several worker nodes here. We've got 3 worker nodes. Okay. And this is essentially what Kubernetes is. You've got control plane, you've got 3 worker nodes. And the aim of this is to try and get containers 1 and 2 managed by Kubernetes. And so these containers are put into the worker nodes. So we've got 1 and 2. And the thing with Kubernetes is it has several different abstractions. That's why it can get very complicated very quickly. So I'll try my best to explain based on what I know, by the way. So feel free to correct me if you're listening in and you are a Kubernetes expert and I'm clearly not explaining it correctly or misunderstanding something. So feel free to drop in. So yeah, this is our containers. This is our inside our nodes. So if we just zoom out again and then focus on the control plane. So the control plane, it's also called a control plane node. So we'll just call this control plane node. And it's also made up of several different things. And the most important things that are in here is we've got a Kube API server. We've also got Kube, that's terrible. Kube API server. You also got ECD, which is the database. You've also got the scheduler. I'm just going to call it KScheduler. And then, we actually might have to make this bigger. So let's just, oh, no! Okay, let me just, yeah, this is better. Okay. We've also got a KScheduler, and that's the thing that schedules the nodes, the worker nodes. And then we've also got the Kube, we'll just call it K controller manager. And that controller manager looks at the state of the cluster. The database holds the state of the cluster. So K controller inside the control plane node manages the state of the cluster, whereas the database holds the state. Okay. And then optionally, you also have cloud controller manager. And this is optional. It's not needed really. It's just an optional thing. But this again links into AWS. I forgot the rest of them, Azure, GCP, and all of the other cloud providers to then spin up other resources if you need to. That's directly part of that cloud service. So for instance, if you want to create load balancers, you can do that with the cloud controller manager. Okay, so that's essentially the most important sections of the control plane node. And this is more of the brain. So, oh gosh, sorry. So this is the brain. Oh, I can't even draw a brain. Wait, I'll just make this pink so you understand what I mean. So this is a pink brain. Oh, that's not helped at all, has it? This does not look great. Okay, so this is the brain. So that's the thing that controls the whole cluster. Okay, and then we also have, if we just move on to the worker nodes. I like to think of the worker nodes as actually, I've got a better idea of how to explain this. Okay, so control plane node is like your boss or your manager. Your manager tells you what to do, and then your worker nodes is you or other employees. And your manager, i.e. the control plane node, says, hey, I want you to schedule this piece of work. I'm really going far with this analogy, but we want you to schedule this piece of work. And you can do that yourself as the worker node. You take on that task and then you do it. So if we just go back into this worker node, it contains the container runtime. So the runtime refers to the container. So how the container runs, the container runtime. So I'm just going to put a note here. So it contains container runtime. It also contains kubelets, which that's the way it talks to the API server. This is how it, you know what, I'll do that in a different color, but yeah, you get the idea. You have kubelet, and you've also, slipped, sorry. And you've also got kube proxy. Okay, so container runtime, kubelet, and kube proxy. Those are the main things that are in the node. Let me just zoom it. Let me just triple check I've got that correct. Yep, kubeproxy, cool. And then let's just go a bit deeper and talk about the different like abstractions and stuff. But let me just do this in purple. Like I said, kubelet talks to API server, and so does kubeproxy, I think. Oh no, kubeproxy is networking. But yeah, let's for now link, that's how they link together. You have kubelet and kube API server that talk to each other. Cool. And then let's just talk about some abstractions. So you've got a Kubernetes object called pods. And these pods, I'm just drawing them here. I'll do them in a different color so it's a bit more clear. You've got pods, and then still this is the container, remember, this 1 and 2. So the pod Kubernetes object contains the container. So this is how it looks. The further down we go, the deeper down we are. So you've got your cluster, you've got your worker nodes, you've got your pod, you've got your container. And I know from doing a bit of the CICD revision, the pods create the container using a thing called like a definition file, a pod YAML file, and you basically explain in key value pairs. It's written in YAML. It just says, hey, I want this container in this pod. And yeah, that's essentially what it looks like. But it can get quite confusing. And I think the deeper you go into Kubernetes, the more you're like, all these abstractions, I don't understand what is going on. But yeah, that's the simplest one, I think, to understand. And so the kubelet, we talked about that earlier, that is the Kubernetes API. So that essentially talks to everything. And for example, if you're in the command line and you're using kubectl or kubectl, some people say, the Kubernetes API is the one that authenticates you. It's the one that sees that you have the correct roles to do whatever you need, whatever it is you want to do. So like if you want to see all the pods in the cluster, it checks that you have the correct permissions for that namespace or whatever, and make sure that, you have the rights to delete a pod or retrieve different resources and stuff. So yeah, I think that's essentially what this does. But let me just quickly talk. Oh no. Let me just quickly talk through the scheduler. So this is also a very important part. So this scheduler, can we guess what it does? It schedules the different pods, and it schedules the containers. So for instance, you want to schedule all the different pods to then schedule the containers. It schedules it for you. That's why it's called a scheduler. And when it does that, it just schedules it. It doesn't start any workloads or anything like that. It just purely for scheduling. And so, for instance, the scheduler specifies, the scheduler understands from the user. So as a user, I want this pod to go in X, or I want it so that it is done at this time or whatever. That's what the scheduler does, and you can specify when you want the containers or the pods or whatever to be scheduled into a specific node. But yeah, and essentially that's it. So those are the different like abstractions. I think I'll quickly. I'm just going through my notes to make sure I understand these things. Oh, actually, now we're on the topic of scheduler. Oh gosh, I need more milk. 1 second. The reason I brought up scheduler, I remember now. The reason I brought up scheduler is because we've got if this node dies, so let's just pretend this node dies, we've lost our pod and we've lost our container. And now it's like, well, that application isn't running anymore. What do I do? What do I do in that situation? So we don't want it so that just one failure of a node will destroy it and you can't really do anything else about it. So what we do is using the scheduler, there's quite a few smart things that you can do to make sure this is constantly up. So let's just write it down in this small space. So the scheduler can make sure that, it uses different Kubernetes objects, I believe. So you've got replica sets, deployment, stateful sets, daemon set, jobs, cron jobs, to make sure that everything is all set up, I think. I just want to triple check that actually, because kube scheduler. Let me just triple check. Yeah, so the scheduler is a plain process which assigns pods to nodes. Yeah. Yeah, so it assigns pods to nodes, but now I'm getting confused with like replica sets. Is that just a separate? Oh, okay, cool. I think that's a bit different. Okay, cool. Let's just so let's just finish this part as schedules pods to nodes. Cool. And then let's just look at I don't know, let's go a different color. Let's go green. So we've also got these different Kubernetes objects. So we've got, I think these are the most important ones, replica set. We've also got deployments. We've got stateful sets. We've got daemon sets. And these, all of these make sure, actually I'm going to do it the other way. All of these make sure that there's always a number of pods running, or it just like maintenance of pods. So replica set, what that does is it ensures X amount of pods are running at a specific time. So multiple copies of the pod definition. Oh, actually talked about this yesterday. So yeah, so this controls how many pods at a time. And then deployments controls the replica sets, which then controls the pods. Another abstraction. I told you, just so many abstractions here. So controls the pods, stateful sets. This is for, I think it controls like stateful applications. So applications that require states. And then daemon sets make sure that there's a copy of pods in nodes. Like, let me just Google stateful sets, because I'm just trying to understand stateful sets of value. So it maintains pods with like a sticky or a stateful state. Stateful state. Yeah, that makes sense. Okay. Yeah, the reason I'm just still talking, I'm still thinking about this was just want to make sure I've got it right. Yeah, I think I've got it correct. I think that's what I understand it as. Yeah, okay. I think we'll leave it at that. And you also have jobs and cron jobs. And, oh gosh, like, I think this is what it looks like in a nutshell. So if we just zoom, yeah, we have zoomed out, haven't we? So at this point, initially, what we wanted again with this Kubernetes cluster, what was the point of it? It was to try and get our containers into the cluster. And the way we do that is by putting it in worker nodes. The way you put the containers in the worker nodes, you need the control plane, i.e. your boss, to tell you where to put it. So you have a scheduler. Your scheduler puts it in the nodes, puts your container in the nodes. The containers are specified using a pod. A pod has the container now. and then that's what the scheduler does. However, you have other Kubernetes objects. You've got your replica sets, you've got your deployments, you've got your stateful sets, you've got your daemon sets, and all of these maintain your pods to make sure that you have a certain amount of pods at any one time. You have a certain amount of pods at any one time. So for instance, you've got a replica set. A replica set controls the pods, and then the pods, so the replica set states like, it's also a Kubernetes object, which means you can specify it using a YAML file. We've got a YAML file that of your replica sets that says, hey, I want X amount of pods at any given time. And so that's what the replica set says. And then it checks the worker nodes. And if it only has like one pod and you specified 2, it's like, hey, why is there not 2? And then it creates the second pod and you actually specify what that pod looks like and which pod it is based on inside that YAML file. so many abstractions. Yeah, Tom said, I hate all the abstractions. And yeah, it is very, very complicated. And then you have your deployment. So that takes it a step above. Your deployment controls your replica sets. And so it's a similar thing where it's like, it should have a replica set that is present, so it indirectly affects the pods, if that makes sense. So the official Kubernetes example or a definition of a deployment is it provides declarative updates for pods and replica sets. So when you describe the desired state in the deployment controller changes the actual state to the desired state. So you can define deployments to create new replica sets or to remove existing deployments and adopt their new resources with new deployments. I feel like that's just such a mouthful. Does that really make any sense? Like, I'm looking at a YAML file right now. The spec has 3 replicas. And, oh yeah, it selects it using different labels, okay, and it has different metadata, cool. And then as part of that, it has the containers. See, this is the thing. It gets really confusing at this point, and you really need to think about it because there's so many different layers. So they've talked through an example. We've got a deployment named Nginx deployment. The deployments creates 3 replicated pods that's indicated by the replicas field. And okay. So you create a deployment, you've got one deployment. Oh yeah, and then the deployment is also good for the rolling strategy and stuff, but I think that's like way too deep. That's like CICD stuff, so I'm not going to go into that. Don't want to fill my brain with all of that too. But yeah, that's essentially what it is. Like, let's quickly just talk about volumes in Kubernetes. I just want to get a diagram up to make sure I actually understand it. Okay. So obviously volumes is very sort of a weird one in Kubernetes because everything is ephemeral. So if you store things into a volume, you don't want it also to be ephemeral because then you lose all your stuff. You really don't want to lose all the data that you've put into a volume. So you can specify sort of different things. So you can actually create a volume as part of pods. And then volumes can share data between containers in the same pod. And there's a container storage interface, CSI, which writes a plugin that can be used in Kubernetes. Let's just talk about persistent volume and persistent volume claims. So persistent volume, let's add to the diagram. Okay, let's just call this 2 now. This is 2 nodes. And then let's just remove this. Okay, and then let's add a volume. So, like a persistent volume. That's a persistent volume, and this persistent volume is exactly what it says on the tin. It's a persistent volume. And this is just some storage, and it holds like information like type of storage, volume size, etc. And then see, okay, this is where I get even more confused. I remember Googling this before. Volumes in Kubernetes. So we've got, okay, I need like a sidebar or something. Persistent volumes. Mm-hmm. Okay, so a persistent volume is provisioned a similar way as like other objects, I believe. PVs are volume plugins, like volumes, but have a lifecycle independent of the pods. Oh yeah, so the reason it's called a persistent volume is that if a pod dies, it doesn't really matter, it doesn't really care, it just sort of exists. So yeah, that's why I'm having it there floating. Whereas a persistent volume claim is a request for a storage by a user, and it's similar to a pod. Okay. It consumes node resources. Oh, okay. I'd like to see a diagram actually of a PVC and a PV. I'm a very visual person. I don't know if you've been able to track that. Oh. What's the conceptual difference between persistent volume? Despite their name, they serve 2 different purposes. An abstraction for storage, PV, and a request for such storage, PVC. Together, they enable a clean separation of concern. So you've got someone provisioning a PV, and then you've got a PVC. The storage admin focuses on provisioning PVs, ideally dynamically through defining storage classes, and developers use a PVC to acquire. Okay, so these sort of like, PVC needs a PV to then be used in the pod. Is that correct? So it sort of keeps them separate to each other, I guess. Okay. Okay, that makes sense. And yeah, you know what? Before we like wrap up this, another thing I really wanted to go through is just service mesh and where it would go on my diagram. Let me have a look. I'd like one for Kubernetes. I think sort of talked about it yesterday, but I feel like it just didn't stick. Oh, I forgot about namespaces. Let me just go through that quickly. But you've got a namespace just allows you to separate, like create like little virtual clusters inside the cluster. I really like the way they described it. It's like a folder in your computer, so you can create different folders to organize your workload and files. And it's a similar thing. So if you want to separate different pods, you can do that further by different nodes. You can do that further. You can separate it even further. So you can see from my diagram already, it is quite confusing because the more you build on top of it, the more you throw things in, and you have to take a few steps back, and then you're like, okay, if I go into this cluster now, I need to know which namespace I need to be in to then find the correct pod, and that pod has my container, and that container has my app. To get the level of abstraction is just so many different layers. You really do need to, truly like think about it a bit more. So I'm still trying to find the service mesh diagram to explain it, but I can't find a good enough picture. It's one of those things that I think I understand what it is. It's like a networking thing, just to make sure that, let me just, oh, I can't search. No, I can. Service mesh. So yeah, service mesh manages network and allows communication between services. We've got Istio as a good example. But where would I go on my diagram? You can write a config file, which you can tell. Control plane, that doesn't need to go there. Yeah, but that's the same separate thing. Where would it go in where would Istio go? Istio, Kubernetes, architecture. It's so wild that you can't find this. Like, okay, here you go. I guess it's just an overarching thing for all networking stuff, right? Gosh, it's so many layers of just stuff, isn't it? Okay, I think I've got a good idea. Okay. So you've got, we need to make my cluster bigger. Oh my gosh, I did not draw this very well. Let me just, oh no, that's not good at all, is it? So what we've got here is, let me just make this a different color in purple. Oh no, I thought I selected purple. Okay, so here we've got a, this is like an Istio control plane, which is like a service mesh. Okay, this is a very, very messy diagram, as you can see. And this Istio control plane is the service mesh, which has certain like policies and rules of how the different pods will talk to each other, I'm guessing. So it controls, like, it defines the traffic flows from like service A to B. So say this is this pod. Oh, the pod needs to increase too. Okay, this purple part is a service. It says service 1 and service 2 for pod 1 and 2, which contain container 1 and 2. And yeah, for it just defines how it talks to each other, I guess. It controls this whole flow. Whoa, that gets complicated. It uses like envoy proxy and stuff. Haven't even gone into like proper networking yet. You know what? I might actually do that in a different color in arrows. Let's do it in like lightish purple. So different containers should be able to talk to each other. And I'm just trying to find all the different service types. Oh gosh, there's also services and how to expose them. Oh, it's so overwhelming. You can really go down a deep hole here. It's like, what? Yeah, that's the whole thing, I think. Services and how to expose them. Like, why would you need to add extra abstractions onto Kubernetes for networking? It's already complicated enough. It's just, what even is going on? So you've got a service which uses a selector, and it exposes different pods. It can use it to expose different pods for the networking stuff to sort of flow through. You've got cluster AP. Okay, I think this is, my brain is like exploding right now. It's so complicated. I think I need a new diagram to explain this next part, but essentially, I think what we're going to do is we've got a service. I don't know if I can fit this in my diagram. Let's just... So this is a service, right? And this helps control like networking. And it uses this by, this has a little label, and this is called a selector. And this is usually a tag. So these tags could say app 1. And then the service for it to work, it looks for app1. And then it specifies, once it finds app1, it's like, hey, yeah, the network can go through here. You can talk to these things because they are labeled app1, or they are labeled a specific way. Yes, essentially, I think that's how it goes. Let me just, Kubernetes service. Is that the same as a service mesh? That is my question. So you've got traffic going in. Oh, this is, I should have had my put my service up here somewhere because now it doesn't make sense. But this is traffic going in. This is a terrible, terrible diagram. I hope no one like follows this specific diagram. But so we've got ingress traffic. Oh, that looks terrible. Ingress traffic going in, and then it can select the specific pods and where the traffic is going to go based on the tags of the pods. And that uses cluster, you can specify a service to specify cluster IP, or it can be node port, load balancer, external name. Okay, yeah, okay, that makes sense. Right, so, hi. Hi, everyone who has just joined. I'm like nearing the end. Who is this? Rachmat Nadi? I'm so sorry. Like, I want to go on your profile to see if I know if we've spoken before, but I don't know how to. But nice to see you. Thanks for joining. Yeah, it is very complex. I'm trying to. It's not even a very good diagram, if I'm being honest with you. So it's a service. In Kubernetes, service exposes an application running a set of pods as a network service. Yeah, I just need to look at a YAML file. Okay, so I'm looking at a YAML file now. You've created a service. In the specs, you've created a selector, and the selector looks for the label that says my app, and that exposes TCP port 80. Oh, right, okay. So this specification creates a new service named My Service, which targets TCP port on 9376 on any pod with. Okay, right. Okay, that makes sense. So this service could say it's looking for app1, and then it says, hey, this pod is labeled app1, and in that case, it will target the ports because you specify which port you want to target it, and then in this case it could be port 8080. Maybe 8080 is not a good example, but you know what I mean. Kubernetes assigns the service an IP address, which is called a cluster IP, which is used by the service proxies. Ah, okay. Yeah, okay, I think that makes sense. I'd like to draw it out, I think, to make it a bit more clearer. Huh. Oh, you probably can't see what I'm looking at. I'm just on Google looking at specific examples. Oh, this is a really good one. An introduction to service types. You've got traffic going into the cluster, it goes to the service, which then finds the pods using a selector. Node port, you have traffic going in to a node, then goes to the service, then goes to the pods. That makes sense, node port. Then you've got a load balancer where traffic goes into a load balancer, then hits the service. Then you've got external service where the pods talk to the service and then that talks to an external service. Yeah. Okay. I feel like that's a whole... I feel like I need extra space. Can I create extra space here? Oh, I can add a layer. This is nice. Yeah, that's the stuff. Okay, let's look at this then. I just really want to complete this section. I can't switch this live stream off until I get through this. So we've got a cluster. We have the different we've got the different types of services. We've got cluster IP. We've got node port. We've got load balancer. And we've got external name. So with cluster IP, essentially we've got a cluster. You know what, let's not make this pink. Let's make it black. What a cluster. Oh, okay. With this cluster IP, it's only internal, it looks like. I'm really conscious that I'm just showing off my head here. I don't know how people look up and explain. So we've got with cluster IP, it's actually traffic inside the cluster. And then you've got a service. Service. And then you've got a pod. Traffic, service, pod. This service object, once you create it, it can select the pod, the specific pod, by using tags and selectors. So in this case, app 1. And then it finds app 1 inside the pod. Cool. So that's internal, because that's inside the cluster. Node port, on the other hand, you have traffic coming outside. You have an object called node port, or just node, I guess. Oh, is that just a node object? Node port. Node port is an extension of cluster IP service, a cluster IP to which the node port service routes. Exposes service on each of the node's IP address. Oh, so that's not an object, it's just a node. Okay, cool. Let's just remove that part then. So it's an extension of the other one, cluster IP. External, we've got our node. Then it goes to our service. Then it goes to our pods. And the reason this works is it opens up a port from external traffic. Cool. And then the load balancer. This is quite I didn't give myself enough room, but we've got traffic coming in. We've got a LB here. It goes into the cluster. We've got our service here. And then it goes into the pods. Okay, so that's external. Both of these two are external. Whereas this one is inside, it's more internal. Then we've got external name, which is hello Gabriella Oliver, vask.tech. Don't go on that link. I don't know what it is. Okay, and then we've got external name, which I guess is the other way around. We go pods, service, then external service. Let me just read that one. Service types of external map a DNS to a DNS name, not to a selector. Oh, to a specific DNS name. Yeah, that makes sense. For example, foobar.com. That's a terrible example. Never use foobar on anything. Okay, so the example looks like it's an external name spec service and it essentially goes outside. There's another type called ingress to expose your service. Ingress is not a service type, but acts as an entry point for your cluster and can consolidate your routing rules into a single resource. So we also have, let's do this in a different color, ingress, which looks at entry point to a container. Cool. Yeah, I think I'm happy with that. That sort of makes sense to me. Let me repeat it back to all of you. So we've got different services. A service is a Kubernetes objects that help with networking inside and outside your cluster. So you've got we've got 4 different types of services. You've got cluster IP, and this is more about traffic inside your cluster. You can create a service which then can select a pod based on the selector, like tagging, essentially. You've got a node port, which takes in external traffic. You have a node, it exposes the port. That then goes into a service, then goes into the pods. A load balancer takes in traffic externally, you provision a load balancer. The traffic goes from wherever it came from to the load balancer to the servers to the pods. Then you have external name, where it uses a DNS name. So that could be google.com. So you go from pods to the service to the DNS name. Another way you can get traffic inside your cluster, ingress traffic going inside the cluster, is using ingress, which isn't which can also expose your different services, but it's not a type of service in itself. So it's a similar sort of thing. Amazing, look at that all on top of each other. That is not great. Look at that. And that is what I learnt today. Yeah, I think that makes sense. Yeah, that does make sense. Cool. Well, I hope I explained that correctly. I am good for a quick break, but that was so much fun. And oh my gosh, I've been streaming for almost 2 hours. But thank you so much to everyone who has joined. I'll see how I get on with my exam. I hope to take it soon. I'm also hoping that it is my first time doing this sort of exam that's not like an AWS exam. Also, there's not a lot of content out there yet, so I'm hoping to see how that goes. Maybe it's, you know what, like at the end of the day, if I do sit it, I can see how I feel about it and also retake it, because that's also an option, if it's possible, because it came with the sort of course that you bought. But yeah, thank you for watching, and I will head off now, have a break, go for a walk. But thank you for watching my stream. More of these to come, I think. Have a lovely day, everyone.